In this quick tutorial, we're going to look at using our graphical calculator to help us calculate probability distributions. Okay, so if we look at this quick scenario here, the number of customers that come into a cafe and order a mocha can be modeled by a binomial distribution, the probability of 0.65. The question is, what is the probability that out of the next 10 customers, exactly 4 order a mocha? So I've made a little graph here already. 10 is the maximum customers you get 0. We want to know exactly 4. So we're looking at binomial distribution. So on our calculator here, we click on menu and we choose stat. So we can either click on the 2 down here or use the arrows and go across and execute. So we've got a distributions button here, which lines up with F5. Then we've got normal, binomial, and we've got more options, but we want binomial for this time. Now, we want the exact answer of 4. So here, the exact answer 4. So it's a perfect score. So click on this one here, binomial, PD, binomial, I call it a perfect score, binomial perfect distribution. Okay, so variables, if you haven't got these variables ready to enter, then you just need to click the variables button, F2. But you can see here we're ready to start entering. So X is our number of interest, that's 4. And then execute. Our numerical, that's the most that we could possibly get, and that was 10. The probability that remains constant throughout, which is an assumption of course, 0.65. Hit execute twice, and it gives us the probability of 0.0689. 40p is good. Okay, so the different type, that was a perfect score. Now the next problem we've got here, what's the probability that less than 5 of them order a mocha? Now I've drawn a picture of less than 5. 5 is not included. So our calculator always goes with the less than or equal to. So our calculator, this calculator is going to work with a probability of X is less than or equal to 4. So therefore our X is 4. But we need to exit out of this and go into distributions again. And when we go into binomial this time, we want to see cumulative. It's going to accumulate the values of 0, 1, 2, 3, and 4. So cumulative distribution, variables already there. We want 4 again. We want 10 again. And the probability, everything's remaining the same in this question. That's uncommon. So we've got a probability here, binomial, cumulative distribution, accumulating all those 5 values, 0.09493. Okay, so that's binomial. The others are exactly the same, Poisson distribution. There's one little glitch in the second part of this. The average number of grass scrubs in 1 square kilometre of land is 25. What's the probability that there are average number of grass? I forgot to put the perfect score of 25. What's the probability there are exactly 25? The average. Okay, so let's exit out of this. Distribution. Now we can't see Poisson here, so we go across here for extra options, and there's Poisson under F1. For exactly 25, we've got the perfect score. Variables already there to add in. We want X is 25. Hit execute once. There's the mean, the average number, the lambda. The lambda was 25 as well. That's the only parameter. Probability of 0.0795. Okay, but what if we were doing a cumulative here? This is where it's a bit different. What's the probability there are at least 20 grass scrubs in 1 kilometre square? So I've coloured in at least. Now you know how I said the calculator goes less than or equal to? So all it can do is less than or equal to 19. But we have to remember that all probability is 1. So if we go 1 minus the unshaded pieces leaves us the shaded pieces, and that's what I've written here. 1 is all probabilities minus the unshaded. So the calculator likes X is less than or equal to 19. Okay, so let's just exit out a bit. Distribution. We want the Poisson. cumulative this time. We want for our x, we want 19, less than or equal to 19. Execute. The mean stays the same. Execute again. And we've got the probability there of the unshaded of 0.1336. So our answer to that question will be 1 minus 0.1336. And that's all there is to it. Now your normal distribution is exactly the same. Exit out. Distribution, normal. Generally we use a cumulative unless we're doing a continuity correction. Lower end, upper end. Okay, so let's say we're looking at less than 60, some situation. The lower end is all the way to the lower. So we want a really small number, all the way less than 60. So I'm going to put negative 9999, really, really small number. The upper end is 60. And I'll just make up some random standard deviation comes up first. Let's make a standard deviation of 2.3. And an average there of a mean there of 58. And execute. So we're getting a probability in there of 0.8077. Okay, it's got the Z scores, but the probability is what we're after. Okay, so there are all of your options, distributions, normal, binomial, Poisson, and if we go back and have a quick look at the binomial, you can see that binomial has, on some of your calculators, they'll have an inverse there, and you'll see that it's limited, and this is a slightly older calculator, obviously, but we've got an inverse for the normal as well. That would only give us the x value, not the mean and the standard deviation, the x value only. But you will find that when you go trying to put things in, that you need to know the mean excuse me, and the standard deviation. So the only thing left is the x. Okay, so that's how you use your graphical calculator. If you're wanting to find any other functions back in the maths thing, if you're looking for factorials, normal math parts options, and then you want to go across to find probability, there you'll find your factorials there and your combinations there as well. Okay, that's the end of that tutorial on using your graphical calculator.